Okay, for number 4, for statement number 4 here, guys. Okay, angles A and angle T are right angles. Or a better way to say that, we can write here angles WAT and LTA are right angles. Okay, so they're right angles. So, and a better reason for that. So we all know that a rectangle has 4 right angles. But a better reason for that could be, okay, we can write here all. Okay, so we can write here all rectangles have 4 right angles, have 4 right angles, and here at number 5, okay, at number 5 we can say that, okay, for statement number 5 we can say that angles WAT and LTA are congruent. Okay, so they're congruent because all right angles are congruent. So let's write that. Number 5, all right angles are congruent. Okay. Okay, and then we can also say that this segment right here at the bottom, because if you notice, guys, line segment AT is being shared by triangles WAT and LTA. So if it's being shared, so that must mean that both of those triangles are sharing one line segment, and this line segment can be congruent to itself. Okay, so we can write here number 6. Okay, we can write here for number 6, AT is congruent to AT, and the reason for that we can write here is the reflexive property of congruence. Okay, and lastly we can say, okay, now we can say that triangles, okay, for number 7. Okay, so let's try to write here. Okay, let's try to okay, number 7. Okay. Okay, so for number 7 we can now say that the two right triangles are congruent. Okay, so number 7. Okay, so let's just write here. Okay, we can write here number 7, right triangles WAT and LTA are congruent. Okay, and the reason for that is the leg or the LL congruence postulate. Okay, or LL triangle congruence postulate. So let's write that. LL triangle congruence postulate. So how did that happen? So we have here AT. Okay, so AT is congruent to itself, and it's being shared by both of these right triangles. And also we have here WA and LT. Okay, so we have here the opposite sides of rectangles are congruent. Okay, so we have here one leg and another leg, and one leg and another leg. Then using LL, okay, the LL congruence, triangle congruence theorem, we can say that both of those right triangles are congruent. And lastly, we can now prove, okay, number 8, okay, we can now prove that segments, okay, WT and LA are congruent, or the diagonals of this rectangle are congruent. Okay, so they're congruent using, okay, so what's our justification or proof for that? We can say, okay, for number 8, we can say that they are congruent using DCPCTC, or the congruent parts of congruent triangles are congruent, because we've already said that they are congruent. Okay, we've already had that proof, and therefore for number 8 we can state, or we can conclude that both of those diagonals are congruent. Okay, so as you can see, that's just one of the applications of the what do you call this, right triangle congruence theorems. Okay, so we have the LL, LA, high A and high L, and so far we've applied LL, and also we can apply the other right triangle congruence theorems in your future proofs. Okay, so let's go right ahead with the second problem. Okay, so let's write here. Okay, let's write here on number 1. Okay, so the givens here are we have here triangle BODR. Okay, rectangle BODR with point A at the middle and BD is congruent to OR. So those are given. The diagonals are congruent. So given that the diagonals are congruent, we want to prove that parallelogram BODR is a rectangle. So how do we do that? So the first thing that we write here, number 1, can write here that BD, okay, you can write here BD is congruent to OR, and the reason for that can be given. Okay, so it's right here, given. After which, we can state here at number 2. Okay, so we can write here for number 2. Okay, so we can state here at number 2 that BO, okay, so segments BO and RD are congruent. Okay, because, okay, the opposite sides, okay, opposite sides of a parallelogram are congruent. Okay, so we can say that. And also we can say, okay, we can also say here at the number 3, okay, number 3, that BO, okay, BO is congruent to BO, okay, and OD is congruent to OD, and the simple reason for that is through the reflexive property, okay, reflexive property of congruence. Okay, so let's change that. So from BO, okay, from BO we change that to BR. Okay, so BR is congruent to BR. The top side and also the bottom side are congruent to each other, or I mean congruent to itself, to themselves. So BR is congruent to BR and OD is congruent to OD using reflexive property of congruence. And for number 4, we can state here that triangles BOD and RDO, okay, RDO are congruent to each other using the SSS triangle congruence postulate. So how did that happen? So we have here BO is congruent here, and AD is congruent to itself, and BR is congruent to itself, and we have here BD is congruent to OR. Okay, so BD, the diagonals are congruent to each other, and therefore we have their 3 sides that are congruent to each other for the 2 triangles. And also using the SSS congruence postulate, we can say here, okay, as an extension of number 4, okay, we can also say that triangles OBR and DRB are congruent, also through the use of the SSS triangle congruence postulate. Okay, for number 5, okay, for number 5, we can write here that the angles, okay, angles BOD, ODR, OBR, and DRB are, okay, they are congruent. Okay, so all of them are congruent also because of CPCTC, or the congruent parts of congruent triangles are congruent, because I've already established that these four right triangles that we found inside of this parallelogram are congruent to each other. Okay, so we could also say that, since if you see here, guys, we have here parallel lines, okay, and there's a transversal. The diagonal can act as a transversal. We can say that these angles here, okay, are supplementary. Okay, so the same side interior angles of the diagonals, okay, of the diagonals are the angles inside of them are supplementary. So we can say, okay, so we can say that BOD is a supplement to RDO and OBR is a supplement to RDB or DRB, okay, using the reason the same side interior angles of parallel lines cut by a transversal are supplementary. Okay, so that can be our reason. That can be our reason for number 6. For our 7th statement, okay, so for our 7th statement, we can write here. Okay, so we can write here for our 7th statement, okay, that the measure of angle okay, BOD plus the measure of angle RDO. Okay, RDO is equal to 180 degrees, and we can also say that the measurement of angle OBR plus the measurement of angle DRB is also equal to 180 degrees, since we've already established that they are supplementary angles in number 6 on the 6th statement. So we can say here on number 7 that we can write here definition of supplementary, okay, definition of supplementary angles. Okay, so we can write that here, okay, for number 7. Okay, so for number 8, okay, we can write here for our 8th statement. Okay, so since here we've already written that they are equal to 180 degrees, and we've also stated here at number 5 angles BOD, ODR, OBR, and DRB are congruent, then we can use, okay, we can use here for statement number 8. Okay, we can write here that measure of angle BOD is congruent, okay, is equal to, or let's say congruent to ODR. Okay, and also we have here measure of angle, okay, measure of angle ODR, and also we can say that the measure of angle OBR, okay, is congruent to the measure of angle OBR is congruent to the measure of angle DRB. And the reason for that is simply definition of congruence. Okay, definition of congruence. Okay, and now that we have established that one, okay, we can use the substitution property of equality here for number 9. So the measurement of angle, okay, so I'm gonna write it here at the bottom so you can see here at the top. Okay, so we can write here measurement of angle BOD. So let's write that clearly. So measurement of angle BOD plus the measurement of itself, since we're using substitution property of equality, is equal to 180 degrees, and the measurement of angle ODR plus the measurement of itself, measurement of angle ODR, is also equal to 180 degrees. Okay, we can write that here for number 9. And the reason for that, okay, number 9, we can write that as substitution property of equality. So where is the substitution? Okay, so if you can see here, RDO. Okay, so from BOD plus RDO, we just substituted BOD here, okay, for this part, and therefore we got there BOD plus itself is equal to 180. And we can write here on the 10th statement, okay, so the measure of 2 BOD is equal to 180 degrees, and the measure of 2 ODR is equal to 180 degrees. So that's just simply simplification or addition property of equality. Okay, so let's proceed with our proof here. Okay, so we can write here at number 11. Okay, we can write here for number 11 that, okay, so let's type. Okay, so we can write here for number 11 that, okay, the measurement of angle BOD, okay, of angle BOD must be equal to 90 degrees, and the measurement of angle ODR, since they are supplementary, is also equal to 90 degrees. And also using substitution property of equality, we've shown this is that BOD and ODR equal to 90 degrees. Okay, using the division property of equality for this statement. Division property of equality. Okay, and then, okay, so therefore we can conclude here on number 12. Okay, number 12 that angles BOD, RDO, DRB, and RBO, okay, RBO are right angles. Okay, And the reason for that for number 12 is simply definition of right angles. Because I've already established that they are right angles here. There are two right angles here at number 11. And also that follows for the parallelogram with supplementary angles. We have here definition of right angles. And therefore, we have here for number 13, we can now say that parallelogram BODR is a rectangle through the definition of a rectangle, because a rectangle is a parallelogram with 4 right angles and 2 pairs of congruent and parallel sides. And we've seen that from our proof, okay? We've seen that from our proof that there are 4 right angles here. This parallelogram, which is a rectangle, has 4 right angles, and also we also see here that these sides are congruent, the opposite sides are congruent, and its diagonals are congruent based from the given, and therefore the parallelogram BODR is a rectangle. And we finish our proof here. Okay, so for word problems involving rectangles, let's read the first problem. Miss Lupita wants to create a rectangular floor plan for her house using the dimensions of a ratio of a golden rectangle. Okay, so the ratio of a golden rectangle is 1. Okay, so for this figure, 1 is to 5. Okay, and where phi is equal to 1 plus square root of 5 all over 2, or 1.618. Okay, so this is the number that you use, the constant that you use throughout your activities and modules also. And for the second story, she wants to create a rectangular aviary with the dimensions half of those of the first story's dimensions. So given that the length of the first story, okay, so the length of the first story is 2 phi plus 4 hectometers. Find its width. Okay, so we need to find the width of the first floor, the perimeter of the first story, and the area of the second story. So first, for this problem, we're given here this ratio. Take note of the ratio because it's the ratio for the length and the width. Okay, this is the length is equal to 1, and the width is equal to pi, okay, of the first story of the house. Now we don't know the value of W. Okay, so first, we must try to solve for the value of L, or the length of the rectangle. So 2 phi plus 4, and our value of phi is equal to 1 plus square root of 5 all over 2. Later, we're going to show the proof on how we got this constant value for phi, and that will be equal to, okay, so that will be equal to 5 plus square root of 5 hectometers. Okay, so that's 5 square root of 5 hectometers. To solve for the width, what we have to do is we have to multiply the length and the value of phi. So we have here 5 plus square root of 5 times phi, and that will give you, the width is equal to 5 plus 3, okay, 3 square root of 5 hectometers. Okay, so now that we know the dimensions of the first story, we can now solve for its perimeter. So the perimeter is equal to 2 length plus 2 width, and we can just simply substitute the value of the length, which is 5 square root of 5 hectometers, and then the value of the width is equal to 2 times 5 plus 3 square root of 5 hectometers, and that will give you a value of, okay, so that will give you a value of 20 plus 8 square root of 5 hectometers, okay, or 37.89 hectometers. Okay, good.